Welcome to this session. In this session, we are going to discuss about the backward difference operator. So let's start by defining what we mean by the backward difference. So let x naught, x1, x2 up to xn be equally spaced mesh points. And let the function y equals to f of x take on the values f of x naught, f of x1, f of x2 up to f of xn respectively are the mesh points x naught, x1, x2 up to its n. Then the backward difference operator of y equals to f of x is defined as backward of f of x is given by f of x minus f of x minus h. Where h is the mesh spacing. Or actually what is called interval of differencing. Now remember when we say the mesh points x1, x naught up to xn are equally spaced, we mean that if we draw, if this x naught, next is x1, next is x2, next is x3, next is x4, the last one is xn, so next one previous is xn minus 1, xn minus 2, so there are several others within here. So these points are equally spaced if the distance between two consecutive points is uniform. So h, this is h, this is also h, 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 and h. So this is the case where you say that the mesh points are equally spaced. So from one to the next one, the distance is uniformly h. Now we can, so this is the main definition or how we give the backward difference of a function f of x, or we can use the notation if we let x to be xk, and then x plus h to be xk plus h, and we let the mesh spacing to be 1, then, so if we call this one 1, 1 can also be written as or be given by of f of x sub k is equals to f of xk minus f of xk plus h minus h, not plus, minus h, which is the same thing as writing backward of f sub k. So remember, f of x sub k can as well be written as f sub k. So this will be given by f k minus, now when you let h to be 1, then this will be written as f k minus 1. Or we can write in terms of the variable y, and we write the backward of y sub k is given by y sub k y sub k minus y k minus 1. So all these are different ways of interpreting or defining the backward difference operator. We can give it in this form, or we can give it in this form, or we can give it in this form, or just from what you have given in one, we say backward of f of x is given by f of x minus f of x minus h. All these things are the same in terms of interpreting the backward difference of a function f of x. Now, so the expression or the equation this is called the first backward difference. So this is the first backward difference. Now, let's define the second backward difference. So simply this power 2 of fk, which will be the same as difference of first difference, applying laws of indices. Now, this will be backward of, by definition, this is fk minus 1, which will be the same as backward of fk minus backward of fk minus 1. Now, by definition, I remember backward of fk means the value of the function at xk minus the value of the function at the previous xk minus 1 step. So this by definition will be backward f of k minus f k minus 1. So I'm defining this first part minus. Now to define backward of fk minus 1, it will be fk minus 1, then minus the value of the function of the previous step. When you are at k minus 1, then the previous one is k minus 2. So fk minus 2. Now opening the brackets, I will give fk minus fk minus 1 minus fk minus 1 minus minus is plus fk minus 2. So which implies that the second backward of f sub k will be given by fk minus twice fk minus 1 plus fk minus 2. So this is what will define the second this is what we call the second backward difference. Second backward difference. Now we can also define the third backward difference. So third backward difference will be backward power 3 fk, so which is the same as backward of the second backward. Now we have already defined the second backward, so this will be backward of fk minus twice fk minus 1 plus fk plus minus 2. And then you distribute the backward operator on each of these functions. So this will be backward fk minus twice backward fk minus 1 plus backward fk minus 2. And then by definition, backward of fk is fk minus the previous value of the function at xk minus 1. So fk minus 1 minus 2 into backward of fk minus 1 is fk minus 1 minus fk minus 2 plus fk minus 2, previous one is fk minus 3. So which will give us fk minus, so this will be minus fk minus 1, this minus 2, so it will be minus 3 fk minus 1. This will be plus, so plus 3 fk minus 2, and then minus fk minus 3. So this is the third backward of fk. So this is what we call the third backward of fk. Third backward difference. Now, similarly, we can define the fourth backward difference of the function f at xk. So the fourth backward of fk will be the backward of the third backward difference. So which will be backward of, we have the answer to this, f sub k minus 3 f k minus 1 plus 3 f k minus 2 minus f k minus 3. So distribute the backward operator to each of these functions. So this will be backward of fk minus 3 backward fk minus 1 plus 3 backward of fk minus 2 minus backward of fk minus 3. So which will be, this by definition will be fk minus fk minus 1 minus 3 into, this will be fk minus 1 minus fk minus 2 plus 3 into fk minus 2 minus fk minus 3 minus into fk minus 3 minus fk minus 4. Now, when you open the brackets and collect like terms, you should be able to get fourth backward of fk is f sub k minus, so this will be minus 4 fk minus 1 minus will be plus, so plus, so 3 plus 3 will be 6 fk minus 2, and then minus, you'll have minus 3 and then minus 1, so it will be minus 4 fk minus 3, minus is plus fk minus 4. So this is what we call the fourth backward difference of fk. Fourth backward difference of actually f of xk or f of x. So then if we check the result for the first backward, so note that first backward of f sub k is f sub k minus f k minus 1. Second, we have gotten the answer to be fk minus twice fk minus 1 plus fk minus 2. And then third, we have gotten the answer to be fk minus 3 fk minus 1 plus 3 fk minus 2 minus fk minus 3. And fourth backward of fk is fk minus 4 fk minus 1 plus 6 fk minus 2 minus 4 fk minus 3, and then plus fk minus 4. There is a pattern here. If you remember the binomial coefficients for the Pascal triangle, we have 1, 1, 1, 2, 1, 1, 3, 3, 1. So this will be 1, 1 plus 3 is 4, and then 6. This is 4, 1. then 1, 5, 10, 10, 5, then 1. There's some relationship with the coefficients of these functions with these binomial coefficients in the Pascal triangle. But you see the first difference, this is 1, negative 1. So it's simply 1 and then negative 1. And then the second difference, we are getting the coefficients, we have 1, minus 2, 1. So 1, minus 2, 1. And then here we have 1, minus 3, 3, minus 1. So 1, then the sign changes to minus, and then plus 3, and then minus. And then here we have 1, minus 4, 6, minus 4, positive 1. 1, then change the sign to negative, then positive, negative, and then 1. So it shows that you can always find other higher backward differences by simply making use of the binomial coefficients and then just alternating the signs of the binomial coefficients. So the first sign is positive, followed by negative, positive, negative, positive, negative, etc. So those are, that's how we find the higher order backward differences from the definition. And the next session will be discussing about the way on how to represent backward differences in a table. Thank you.